Hi everyone, my name is Jamie Thacker, and today I will be presenting on operating system and firewall hardening, specifically focusing on 4 technologies: Microsoft Server 2022, Ubuntu Server 24.04, Windows Firewall, and iptables. These are some of the most important building blocks in IT security. Operating systems are the backbone of enterprise and cloud environments, and firewalls are the gatekeepers that control the flow of traffic. But if these tools aren't configured properly, they can leave organizations open to devastating cyber attacks. This presentation will cover what each of these systems are, how they work, and most importantly, the strategies administrators can use to harden them. By the end of this presentation, you will see how operating system and firewall hardening together create defense in depth. Here's an overview of what we will be covering. We are going to start with operating systems, specifically Microsoft Server 2022 and Ubuntu Server 24.04. For each OS, I'll first provide an overview of what it is and how it functions, and then we will move into hardening strategies that can be applied. After that, we're going to transition into firewalls, covering Windows, Firewall, and iptables. Again, we're going to first talk about what they do, why they matter, and then we're going to get into the specific hardening recommendations. Finally, we'll wrap it up with some key takeaways, the big picture lessons from all of this, and then look at the references used for this presentation. This structure is intentional. It lets us compare and contrast operating systems and firewalls side by side, while also keeping the focus on actionable hardening practices. To begin, let's look at operating systems. Operating systems are the foundation of any IT infrastructure, and their security posture determines how well an organization can resist attacks. We'll start with Microsoft Server 2022, which is the most recent version of Microsoft's Enterprise Server, OS, and then look at Ubuntu Server 24.04, a Linux distribution that powers much of the cloud. For both, I will highlight their core functions and then discuss specific hardening steps administrators should take. Microsoft Server 2022 is the latest release in Microsoft Server operating system line. It is widely used in enterprises for managing identities, providing file and print services, running applications, and handling virtualization. One of its most important features is Active Directory Domain Services, which provides centralized identity and access management. This allows organizations to create and enforce policies for thousands of users and devices from a single point of control. Another key feature is Hyper-V, which allows virtualization so that multiple workloads can run on the same physical hardware. Windows Server 2022 also integrates with Azure, Microsoft's cloud platform. This makes hybrid deployments possible, where some resources are on-premise and others are in the cloud. That's important because most organizations today operate in hybrid environments. Microsoft has published security baselines for Server 2022 through its Security Compliance Toolkit. These baselines provide recommended default settings for security, which are designed to reduce risks without breaking functionality. So when we think of Windows Server 2022, we're really thinking of a system that combines identity management, virtualization, and cloud integration. And because of its role, it is a primary target for attackers. Because of its central role, Windows Server 2022 must be hardened. By default, it comes with some risks: built-in administrator accounts that attackers often target, legacy protocols like SMB v1 that have been exploited in past ransomware outbreaks, and the ongoing risk of unpatched vulnerabilities. Here are some hardening strategies. Apply Microsoft security baselines. These can be deployed through group policy to enforce consistent settings across all servers. They include recommendations like disabling weak ciphers, turning off unnecessary services, and enforcing password complexity. Protect administrative accounts. This means disabling or renaming the default administrator account, requiring multi-factor authentication for all privileged users, and applying least privilege principles so users only have the access that they truly need. Eliminate legacy protocols. For example, SMB v1 should be disabled. This was the exact protocol exploited during the WannaCry ransomware attack, which spread globally in 2017. Removing old and insecure protocols is critical. Enable advanced protections. Windows Defender now includes tamper protection and attack surface reduction rules, which can help stop malware and prevent exploitation of common vulnerabilities. Improve logging and monitoring. Forwarding logs to a centralized SIM allows administrators to detect suspicious activity. PowerShell transcript, which records command line activity, can catch attempts at privilege escalation. Hardening Windows Server is about shrinking the attack surface. Each step removes potential entry points or makes it harder for attackers to escalate privileges. In practice, this means fewer successful ransomware attacks and fewer insider misuse incidents. Ubuntu Server 24 is the latest long-term support release of Ubuntu, a Linux distribution that's become one of the most popular choices for cloud computing and data centers. It uses the apt package management system for updates, systemd for managing services, and AppArmor for mandatory access control. Unlike Windows Server, Ubuntu is free and open source, supported by Canonical, and widely used by developers and enterprises alike. So why does it matter? Ubuntu powers a massive percentage of cloud workloads on AWS, Azure, and Google Cloud. It's lightweight, stable, and cost-effective, which makes it a go-to for hosting web applications, container environments, and critical infrastructure. Its popularity, however, also makes it a target. Attackers scan for Ubuntu systems with weak SSH credentials or outdated software, and once compromised, those servers can be used for data theft, cryptojacking, or launching further attacks. That's why hardening is critical. Ubuntu servers can be hardened with a number of key steps. Stay patched. Administrators should enable unattended upgrades so security patches are applied automatically. Outdated packages are one of the most common ways attackers gain entry. Secure remote access. By default, SSH allows root login, which is dangerous. Best practice is to disable root login, enforce SSH key authentication, and install fail to ban to block repeated failed login attempts. Harden the firewall. Ubuntu comes with UFW, the uncomplicated firewall, which sits on top of iptables. Configuring it with a default deny inbound policy and then opening only the ports needed is a baseline defense. Protect the file system. Sensitive directories like var and tmp should be placed on separate partitions, and security mount options like no dev, no suid, and no exec should be applied where possible to block privilege escalation. Contain applications. AppArmor, which is enabled by default, should be set to enforce mode. This restricts applications to only the files and permissions they need. Monitor and log. Enabling auditd and forwarding logs to a central collector ensures accountability and supports incident response. In short, Ubuntu hardening is about closing the default gaps, patching, securing SSH, restricting network exposure, and monitoring activity. Without these steps, a Linux server on the internet can be compromised within hours of deployment. Now, let's move into firewalls. Firewalls control the flow of traffic into and out of systems, acting as the gatekeepers of the network. We will look at Windows Firewall, which protects Windows systems, and iptables, which is a traditional Linux firewall. Like with operating systems, I will start with an overview and then walk through hardening strategies for each. Windows Firewall is a built-in host firewall included with all modern version of Windows. It uses rules to filter inbound and outbound traffic, and it has 3 profiles: domain, private, and public. It can filter traffic based on the application, service, port, or IP address. It even integrates with IPsec, which allows administrators to enforce encrypted communications between systems. The firewall can be managed locally using the GUI through PowerShell or centrally with group policy. This flexibility makes it scalable for enterprises. So why does it matter? Windows Firewall is often the last line of defense on individual systems. Even if the perimeter firewall is misconfigured or bypassed, Windows Firewall ensures that unauthorized traffic cannot reach critical services. It also helps block malware from spreading inside a network or calling back out to an attacker's command and control server. Here are some hardening strategies. Apply a default deny inbound policy. Instead of allowing everything and blocking known bad traffic, flip the model. block everything by default and only allow what's explicitly needed. Scope rules tightly. For example, if remote desktop is required, restrict it to specific IP ranges instead of allowing all traffic. Control outbound traffic. By default, many organizations leave outbound traffic unrestricted, but restricting it ensures malware cannot exfiltrate data or connect to command and control infrastructure. Enable logging. Both dropped and allowed connections should be logged, and those logs should be sent to a centralized collector. Use group policy for enforcement. This ensures consistency across hundreds or thousands of endpoints. Hardening Windows Firewall is about reducing the chance of misconfiguration and ensuring that traffic rules are both restrictive and visible. On Linux systems, the equivalent of Windows Firewall is iptables. It is a command line utility that interacts with the NetFilter framework inside the Linux kernel. iptables organizes rules into chains. Input for traffic to the host, output for traffic from the host, and forward for traffic being routed through the host. Rules can match on attributes like interface, source and destination IP, protocol, or port, and the action can be to accept, drop, or reject the traffic. iptables have been around since 1998 and remains widely used, though it's gradually being replaced by nftables. Still, because it's so well documented and mature, many enterprises continue to use it. It matters because it allows extremely granular control of network traffic on Linux servers, making it essential for protecting cloud workloads, application servers, and edge devices. iptables can be hardened with a number of key steps. Set strict default policies. Input and forward chains should be set to drop, and only explicitly required services like SSH or HTTPS should be allowed. Restrict by source. Services should only be open to trusted IP ranges or subnets when possible. Use stateful rules. Modules like contract ensure that only legitimate established sessions are allowed. Add rate limiting. This can help mitigate brute force attacks or denial of service attempts. Log intelligently. Drop packets should be logged with limits to prevent log flooding. Persist and test. Rules should be made persistent with tools like NetFilter Persistent and always tested with a rollback plan to avoid accidental lockouts. In practice, hardened iptables configurations ensure that Linux servers are only reachable where absolutely necessary, and they can help detect or resist common attacks. Finally, let's discuss the key takeaways of this presentation. To summarize, operating system hardening comes first because if the base OS is insecure, no firewall can save it. Patching, disabling defaults, and reducing unnecessary services are foundational. Firewalls then act as that second layer, enforcing boundaries and logging suspicious traffic. Together, these create defense in depth, which is the layered security approach modern organizations must use. In conclusion, operating systems and firewall hardening are essential practices for modern cybersecurity. Microsoft Server 2022 and Ubuntu Server 24.04 provide the foundation for enterprise and cloud environments, while Windows Firewall and iptables act as protective barriers to control traffic. By combining baseline hardening, strict access controls, continuous patching, and strong firewall rules, organizations create a layered defense that reduces risk and increases resilience. Ultimately, hardening isn't just about technical checklists. It's about ensuring stability, protecting sensitive data, and maintaining trust in the systems we rely on every day. Here are the references that supported the material in this presentation, including documentation from Microsoft, Canonical, DigitalOcean, and several security organizations. These sources provide more detail if you'd like to explore the configurations and strategies further. Thank you for your time.